Hi friends, today's topic is thermodynamics. Thermodynamics is a very important part in chemistry, actually in physical chemistry. So in thermodynamics we have to know at first what is thermodynamics. Thermodynamics is the microscopic part of macro science which deals with internal conversion of heat and mechanical work. That is, a small part in a large universe, a small system in a large universe is thermodynamics, which relates between heat and mechanical work. And in thermodynamic system, there are such terms which we have to know. That is thermodynamic system. It is a microscopic part of universe in which internal conversion is considered. Internal conversions are considered surrounding all the part outside the boundary wall of the system is called surrounding, and universe is system and surrounding collectively defined as universe. Now there are three types of thermodynamic system present. 1. Closed system. 2. Open system. And 3 is isolated system. In closed system, here mass transfer does not occur. Here energy transfer occur. And in open system, mass and energy both transfers. But in isolated system, mass and energy does not transfer. That is, mass and energy change will be zero in isolated system. Now, in thermodynamics, there are intensive and extensive properties present. What is intensive and what is extensive property? Suppose one system is divided into many parts and only one part can explain the property of all the system, then the system will be, or the property will be, intensive property. Like chemical potential. Chemical potential is a intensive property. Chemical potential, that is equal to free energy divided by mole. That is, chemical potential of overall system is same, does not depend upon the mass of any divided part of the system. Whereas in case of extensive property, if a system is divided into portions and it is found that any property of divided part is obtained by summing up the properties of the all portions. Suppose mass of a system. If I divide a system in many parts, then mass of the overall system will be equals to mass of individual system, equals to sum of the mass of individual divided system. So mass will be an example of extensive property. Now, two important terms in thermodynamics is reversible and irreversible reaction. What is reversible reaction? Reversible reaction means a reversible process is a small change should be carried out in such a way so that at each and every step the system must maintain a virtual thermodynamic equilibrium, and the reversible process is allowed to happen slowly from one step to another until the whole desired and specified change is achieved. The reversible process can be reversed, which means that if the condition of the reaction is opposed, then the process The process is carried out in opposite direction by changing the state variables by the same amount at each and every step involving some number of steps. The work done in the forward direction will be equivalent to the same in opposite direction. That is, total work done in case of cyclic process is 0, because work done in reverse process will be same in amount with for backward process but opposite in sign. So total work done will be 0 in case of cyclic reversible process, but in case of irreversible reaction, this process cannot be reversed. Now, to understand reversible and irreversible reaction, at first we have to consider suppose a reaction which is involving only one state. Suppose a reaction involving one state but where one step and two states are involved. Suppose a reaction having two states which has temperature T, P prime, V prime, and another has T temperature P double prime, V double prime. This is an isothermal change as T is fixed. Now it has two steps but the reaction is one step process, and here V double prime is greater than V prime. Here volume expansion occurs. Now if we increase the number of states, if here three number of states are present, then two steps are involved. These are the states 1, 2, 3, and these are the step 1 and 2. If we increase the step, as well as state will also increase. If there is n number of state, then there will be n minus n plus if there is n number of states, so there will be n minus 1 number of step. Now here the variables are temperature, pressure and volume. Now if we increase the number of step as well as number of state, then the difference between state variables, suppose here difference between two state variable, that is volume, is delta V, then difference delta V, that is equal to V double prime minus V prime. Then if we increase the number of state or step, then difference between state variables increase. So that two successive steps is decreased. Different here state variables are V prime, V double prime, and difference is delta V. When the number of state increase, here three states are present. If a process involving 4 states, then with increasing number of state, then difference between two state variable decrease. That difference will be between two successive steps, the state variable in two successive steps. Now if we increase when infinite number from finite number of step, when infinite number of step will form, then this delta V, that is this difference become differential, that is dV or dP or dt. So difference between differential with when number of step becomes infinite from a finite state. Now in a true reversible process, in case of reversible process, what I said that in reversible process equilibrium condition will maintain, equilibrium condition between every state will maintain, and in case of reversible reaction, the reaction can be easily reversed, and here infinite number of steps are involved in a reversible reaction. So difference between two successive state variables becomes differential in case of reversible reaction. Hence, in case of reversible reaction, the difference between state variables becomes differential, and in case of irreversible reaction it becomes delta, and in case of reversible reaction it becomes d. So, now what will be the work done value? Work done, as we know, work done equals to force into displacement. Here negative sign will become due to IUPAC system. Hence, force divided by area into displacement, suppose delta L into area. Now area into displacement, that is volume, and force by area, that is pressure. Hence pressure, that is P external into delta V, volume change, that is the work done value. Now when a system expanded, suppose a system having pressure P internal and external pressure is P external. Now if P internal pressure is greater than P external, then internal pressure wants to reduce to achieve the equilibrium with P external, and P internal, if P internal reduce, hence volume will increases, and P and V has a inversely proportional relationship, and P internal then reduced, and volume will increased, and hence at a time P internal will be in equilibrium with P external. And if the opposite condition will be there, if P internal is less than P external, then P internal pressure wants to increase. To increase the internal pressure, volume will decrease, and in first case, as P internal want to decrease, volume will increase, hence expansion occurs, and when expansion occurs, the work done will be by the system on the surrounding, and in case of there, as P internal want to increase, then volume will decrease, and volume compression occurs. Hence here surrounding work done by the surrounding on the system. Now work done in reversible process and irreversible process, what will be? Now in case of volume expansion, P external will be lesser than P internal. P external will be lesser than P internal. Suppose by a value delta P. Now in case of first state, P external 1 equal to, suppose the initial pressure was P0, and P0 minus delta P1 will be P external 1. P external 2 will be P0 minus delta P2, and ultimately P external n equals to it will not be P0, it will be P1 minus delta P2, as P1 was the pressure in the first state, and it will be P1, it will be P2, and it will be Pn will be equals to P n minus 1 minus delta Pn. Now as we know, work done, mod of work done, as there was a negative value in work done, so we take mod value, and mod of work done is equals to P external into delta V. For first state W mod W equal to P external 1 into delta V1. Hence, for nth state, Wn equal to Pn into delta Vn, that is equal to Pn minus 1 minus delta Pn into delta Vn. Hence, work done in case of irreversible process, work done in irreversible process will be summation of work done in all steps W1 plus W2 plus dot 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 Wn, that is equal to summation of I equals to I1 to n Pi minus 1 minus delta Pi. From equation 1 we can write there Pn minus 1 delta Pn delta Vn, and n is replaced by I, so hence I minus 1 minus delta Py into delta Vi. That is the work done in irreversible process. And what will be the work done in reversible process? As I said, in case of reversible process, the difference becomes differential. That is, mod W now becomes, suppose the integration from I to F step. So P internal into in I step minus dP delta P becomes dP differential into dV, and ultimately, as dP dV has a very negligible value, P internal I dV minus IF dP dV, it has a very negligible value, so this value can be neglected. Hence it will become, suppose from volume Vi to Vf, P internal I dV, that is equal to, as we know from our basic knowledge, nRT equals to PV. Hence we can write P internal as nRT, P internal as nRT by V internal, so it will be nRT dV by V, nRT Vi to Vf dV by V, and will ultimately become, by integrating this value, we get work done in reversible process to mod of W equals to nRT ln V final by V initial. Here I and F represent initial, Vi equal to V initial and V of F equal to V final. That is the work done value. Here the assumption is the gas will be ideal in nature, so that we can apply this formula PV equal to nRT. Here the gas is ideal in nature. Now we have to know that reversible expansion, which value will be greater in case of the value of expansion in reversible process or in irreversible process. Now the statement is, magnitude of work involved in reversible expansion of ideal gas from volume V1 to V2 is larger than corresponding work involved in an irreversible expansion against same constant pressure P2. Hence, if pressure is P2, that is constant, so work done in case of reversible reaction will be greater than work done in irreversible reaction when expansion occurs. And how we can prove that? We can prove that is, if V2 is the final volume and V1 is the initial volume, then W reversible, work done in reversible process, will be nRT ln V2 by V1. We can write nRT ln plus 1 plus V2 by V1 minus 1. 1 plus 1 and minus 1 are taken. Now W reversible equals to nRT V2 by V1 minus 1 plus higher term, as if we expand this logarithmic term, then we get this, that is ln 1 plus V2 by V1 minus 1 will be equals to V2 by V1 minus 1 plus higher term. Then it will be equals to nRT by V1 into, by simplifying this, V1 into V2 minus V1 by 1 plus higher term, that will be equal to nRT V1 from assumption that is gas is ideal, so nRT V1 we can write it as P1 into V2 minus V1 plus higher term, that is equal to work done in reversible process. Now work done in irreversible process will be, as pressure is constant, P2 into V2 minus V1, hence W reversible minus W irreversible mod of their value equals to P1 into V2 minus V1 from this plus higher term minus P2 into V2 minus V1. As here expansion occurs, in my next video I will teach about laws of thermodynamics, what is isothermal reaction and adiabatic reaction, and corresponding work done. If this video is helpful to you, please like, share and subscribe. Thank you.